NASA and the Air Force jointly flew the Grumman experimental aircraft X-29 as a testbed to evaluate novel canard control surfaces and cutting-edge materials. The aircraft was among the most aerodynamically unstable in aviation history, despite its promising design. To sustain the aircraft's flight, controls had to be calibrated using a sophisticated method. Even the Russians attempted to duplicate these new technologies due to their tremendous promise. NASA, the U.S. Air Force, and DARPA collaborated on the X-29 project, which was started during the Cold War. The mission assigned to Grumman was to design the ideal fighter aircraft. Grumman was given a fixed-price contract by DARPA in 1981, and it used this money to build 2 aircraft. In 1984, Grumman turned the aircraft over to U.S. military design after testing went well. The design called for a forward-swept wing plane that was striking to look at and the first major product of this kind of endeavor in decades. Because of structural constraints, the United States sought to outperform contemporary aircraft with distinctive features, including aft-swept wings. Although they worked on this kind of aircraft extensively, the Germans gave up on it during World War II. Preventing direction-related wing twist and maintaining the aircraft's modest weight were the primary design challenges. Grumman had to modify the F-5 fighter airframe and acquire new materials to accommodate the stronger wings. Additionally, they suggested alterations to the F-16 Fighting Falcon, yet this concept was quickly rejected. The forward-facing design of the X-29 aircraft presented weight issues since it was brittle without reinforcing. A novel blend of composite materials, now commonplace in both military and commercial aircraft, was chosen by American engineers. The wings would twist due to the aerodynamic lift, causing a structural breakdown. The carbon fiber composite material was bent and twisted without sacrificing weight by using an isotropic elastic coupling. A laminate introduced by the X-29 created a link between bending and torsion, enhancing lift and pushing the wingtips upward. By properly resisting torsion stresses, the coupler reduced lifts and prevented wing twisting. By lowering the leading edge, this decreased loads, avoided aeroelastic divergence, and enhanced material performance. Compared to other planes of the time, which had 5% instability, the proposed aircraft had 35%. This posed an unparalleled difficulty, possibly rendering the aircraft unsuitable for flight. Before prototypes were finished, test pilots started to feel nervous. The team decided to use a 3-surface design with 3 longitudinal controls on the aft streak control surfaces and canards on the wings in order to solve this problem. With trim where the center of gravity was off and a lower amount of wave drag, this design minimized drag without a fail-safe device. With this strategy, the group was able to address the problem efficiently and at an early stage. The arrangement and center of gravity behind the aerodynamic center caused the unstable aircraft. Forward canards and rear flaps were employed by the engineers, and they were managed by 3 redundant computers. Errors were decreased by the flight control system, which can make 40 Hz adjustments in a second, and 3 analog computers that are equally redundant. Because one computer supplied measurements and evaluated the other, redundancy made the system almost perfect, allowing for the early detection of problems. Experts came to the conclusion that on a typically configured plane, the 3 computer systems had the same chance of failing as ordinary mechanics. Christian Galter, the historian at NASA's Armstrong Flight Research Center, underlined the significance of having a digital flight computer aboard the aircraft. He asserted that before the pilot could evacuate, the aircraft would have crashed around him if all 3 flight computers had malfunctioned simultaneously. The mechanism was essential to the flight route of the aircraft. Chief Test Pilot Chuck Sewell finished and tested the first X-29 aircraft on December 13, 1984. This was the first American aircraft and the third to employ the forward-swept wing technology. The X-29 became the first forward-swept wing aircraft to reach supersonic speed. Pilots at the experimental testbed complimented the X-29 on its excellent power-to-weight ratio and little turbulence during takeoff. The plane was cleared following 5 days of non-stop flying. After overcoming early instability difficulties during its maiden flight, the X-29 entered a 4-month NASA test program. Because of the 3 computer systems, the plane was dependable and deployable. By August 1986, the aircraft had completed almost 3 hours of research flights. The second model was evaluated for high angle of attack and came with a parachute, but the first model lacked a spin recovery parachute. Although the plane could only turn 25 degrees, it could make a maximum angle of 67 degrees. The 2 X-29 aircraft flew 242 times between 1984 and 1991, with the Dryden Flight Research Center showcasing novel technology and methods. The aircraft had better handling, aircraft control, and structural divergence control. Progress in the high angle of attack of the second model and surface longitudinal control were critical to success. The X-29 proven to be crucial data for the manufacturing of military aircraft despite its future. The X-29 was an experimental aircraft, typical of several aircraft with wings that swept forward. The Russian Sukhoi Su-47, sometimes referred to as Golden Eagle, Barakut Russian, had its first flight in 1997. The collapse of the USSR delayed the development of the Sukhoi, which had been planned since 1983. The Sukhoi was not intended to be an external testbed. Rather, it was designed to be an operational combat aircraft. Due to its forward-swept wing, the supersonic jet displayed exceptional agility and maneuverability, which served as inspiration for a new generation of Russian aircraft. The Russian Design Bureau began testing the SR-10 in 2015, but ultimately decided against it owing to a lack of money. Production of the Sukhoi Su-57, the next generation of Russian jet fighters, is scheduled to begin in 2020. There are rumors that it will have supercruise stealth technology and super maneuverability. It is said to be the first of its kind avionics for Russian land and naval defense. The Department of Defense gave stealth technology priority, leading to the X-29 experimental program's 1992 cancellation, despite it setting several flying records. This new emphasis was incompatible with the X-29's forward-swept wing shape. Some claim that the U.S. pursued more ambitious initiatives as a result of being scared by the superior Russian clone Sukhoi Su-47. A second aircraft was transported to the Armstrong Flight Research Center, and the entire aircraft was displayed in the U.S. Air Force National Museum. These days, visitors to museums are amazed by the experimental X-29. To watch more videos on American bombers, click the link on the left. To watch more than 24 videos on German aircrafts, click the link on the right. Thanks for watching, and don't forget to subscribe.